Assalamualaikum. Welcome to my channel Jahangir'S Science School. Chapter 6, Concept of Mole and Chemical Counting. Now we want to calculate the percentage composition of element in compounds. So percentage composition. So percentage composition of an element equal to atomic mass of the element, mass of the element into number of atoms divided by molecular mass of the compound, molecular mass of the compound into 100% is the formula. Say water, the molecular mass of the water, say the molecular or relative formula mass of water equal to hydrogen 1, and there are 2 plus 16, so 18. If we want to calculate the percentage composition of hydrogen atom, percentage composition of hydrogen atom equal to atomic mass. Atomic mass is 1 and number of atoms 2 divided by total molecular mass of water is 18 gram into 100%. So this is the formula. And percentage composition of oxygen atom, oxygen percentage, so 16 into 1 divided by 18 into 100%. So 88.89 percentage, and here 1.11% of hydrogen. On the other hand, 88.89 percentage of composition. So this is the technique to calculate the percentage composition of an element in compound. So remember, the percentage composition of an element equal to atomic mass of the element into number of atoms of that element into molecular mass divided by molecular mass of the compound into 100%. Now we want to find out the percentage composition of aluminium, sulfur and oxygen in aluminum sulfate. First we have to find out the molecular mass, relative formula mass or molecular mass of aluminum sulfate, Al2SO4 3. So aluminum atomic mass is 27 into 2 plus sulfate, so sulfur 32, oxygen 16 into 4 into overall 3. So 300, after calculation 342 is the relative formula mass. So percentage composition of aluminum aluminum percentage equal to aluminum. There are so atomic mass of the element. So first atomic mass of the aluminum is 27. There are 2 aluminum, so 2, so number of atoms 2 divided by 343 into 100%. Another sulfur is percentage. So sulfur, there are 3 sulfur here. Sulfur atomic mass of the sulfur is 32. There are 3 sulfur divided by 342 into 100%. So, and oxygen, percentage of oxygen sulfur, so sulfate has 4 oxygen, but overall there are power 3, so 12. So sulfur, oxygen atomic mass is 16 into 12 divided by 342 into 100%. So after calculation, aluminum is 15.78%, and sulfur is 28.07%, and oxygen 56.14%. By using this technique, we can calculate the percentage composition of any compound. So percentage composition of compound, percentage composition of an element, we can easily calculate by this technique. Now we'll discuss about percentage composition and empirical formula. So what is the empirical formula? The formula that shows the smallest ratio of the number of atoms of different elements present in a molecule is called empirical formula. So empirical formula tells the smallest ratio of the number of atoms of different element present in a molecule is called empirical formula. There are another type formula, molecular formula. Molecular formula shows the exact number of number of atoms of different element present in the molecules. But empirical formula only shows the smallest ratio of the number of atoms of different element present in a molecule is called empirical formula. How we can calculate or find out the empirical formula from percentage composition? Say percentage composition of different element are given: hydrogen 2.04%, sulfur 32.65%, oxygen 65.3%. So first we have to divide this percentage composition by its atomic mass. Say 2.04 divided by 1, so 2.04. And sulfur here, sulfur 32 percentage, but molecular mass is 32. So 1 and oxygen 65.30. So after calculation, 16 is the atomic mass, so 4. So empirical formula, empirical formula is ASO, so AS2, AS1 and 4. So 2, 1, 4. So AS2, SO4. This is the empirical formula of this compound. So by using this technique, we can calculate empirical formula from percentage composition. We determine the molecular formula of a compound from percentage composition. What is molecular formula? Molecular formula shows the exact number of atoms of constituent elements in a compound. On the other hand, empirical formula shows the smallest ratio of the number of atoms of constituent element in a compound. So main difference is molecular formula shows the exact number of atoms of constituent elements in a compound. Say, look at the example given. Percentage composition of carbon is 92.31% and hydrogen 7.69%. First, we have to divide the percentage composition of element with their respective atomic mass number. Carbon atomic mass number is 12. So 92.31 is the percentage composition of the carbon. So 92.31 divided by 12, so 7.69. Hydrogen percentage composition is 7.69 percentage. So 7.69 divided by 1, because the atomic mass of hydrogen atom is 1. So 7.69. Now we have to divide. We will divide the quotient by the smallest quotient above. So smallest is 7.69, both are 7.69. So carbon equal to 7.69 divided by 7.69, 1. Hydrogen 7.69 divided by 7.69, 1. So empirical formula C1, carbon 1, hydrogen 1, so CH. Now we have to find out the molecular formula. Let the molecular formula be C carbon hydrogen into N. So N is the number, C 8 carbon 12. According to the question, carbon hydrogen into N equal to 78, because the molecular mass of this compound is 78, which is given. So 12 plus 1, 13, so N equal to 6. So molecular formula of the compound is C6H6. C6H6 is the formula of benzene. Assalamu alaikum, welcome to my channel, Jahangir'S Science School. Chapter 6, Concept of Mole and Chemical Counting. Chemical reactions. How we can express a chemical reaction by chemical equation? There are some rules observed to write chemical equation to express the chemical reactions. The reactants, what is reactants? The chemical compound or element which are combined together and produces new element or compound is called reactants. The reactants are written on the left side, and products, the chemical compound which are produced after chemical reaction is called products. The products are written on the right side. An equal sign or an arrow marks is placed in the middle. Look at the chemical equation. Hydrogen and oxygen combine together and produces water, H2O. Here hydrogen and oxygen are reactants and H2O is the product. After balancing the chemical reaction, we can write 2H2 plus oxygen equal to 2H2O. So then we can use equal sign. So an equal sign or an arrow marks is placed in the middle. Number two rule. The reactants and products, the reactants and products are written by means of their symbol and formulas. If there are more than one reactants, if there are more than one reactants, if there are more than one reactants and products, they are written with plus sign. They are written with plus sign. So the reactants and products. So here hydrogen, there are two reactants. So hydrogen and oxygen. So if there are more than one reactants or product, they are written with plus sign. So plus sign is used to join the two reactants or two products. So the reactants and products are written by means of their symbols and formulas. If there are more than one reactants and products, they are written with plus sign. Remember. Now rule number 3. The number of atoms of different element on the left side and the number of atoms of the same element on the right side need to be equalized. So remember, this point is very important. The number of atoms of different elements on the left side and the number of atoms of the same element on the right side need to be equalized. This is called balancing the chemical reaction. This is called balancing the chemical equation. So the number of atoms of different elements on the left side and the number of atoms of the same element on the right side need to be equalized. This is called balancing the chemical equation. Say hydrogen plus oxygen combine together and produces water. So look at the left side of the chemical equation. Hydrogen number of atoms is hydrogen is 2, but on the right side is also 2, but the number of oxygen atom in the left side is 2, but the number of oxygen atom in the right side is 1. So to become equalized, we multiply 2 by 2. So but now hydrogen is 2 2s are 4. So we have to multiply in the left side also by 2. Then we can write 2H2 plus oxygen equal to 2H2O. So the number of atoms of different elements on the left side and the number of atoms of the same element on the right side need to be equalized. This is called balancing chemical equation. For mole calculation, we need to equalize any chemical equation. It's very important. Now, rules number 4. Rule number 4. Sometimes reactions are not balanced in the equation. In such cases, arrow mark is used instead of equal sign. Remember, sometimes reactions are not balanced. In equations. In such cases, the arrow mark is used instead of equal sign. Say H2 plus oxygen, when chemical equation is not in balance, then we use arrow symbol. Now, rule number 5. Rule number 5. Sometimes the physical states of the both reactants and products also mentioned in an equation. It is written on the right side of the element or compound in the first bracket. If the physical state of the substance in solid, then we write, for solid we write S, small s. If liquid, then we write small l. If gaseous, then we write G. When the substance is in the form of aqueous solution, then we write AQ, aqueous solution. Say 2 hydrogen gas and oxygen O2 gas becomes water H2O, then we can write liquid. So this is the procedure. The main objective of the chemical equation is to express which element have participated in the reaction to form which product. That's why it is not always necessary to balance the chemical equation.